Good afternoon. Welcome to the Illinois Sustainable Ag Partnership's 2022 Risk Management Webinar Series. I'm Megan Baskerville with the Nature Conservancy and Chair of the ISAP Steering Committee. We're glad you're with us today as we continue to bust some conservation myths over our 3-week series. For the final installment today, we have a great lineup of speakers challenging the idea that conservation and tile don't mix. Including Dr. Ehsan Ghane, Isaac Ferrie, and Jeff O'Connor. A little bit about ISAP before we begin. Since 2017, ISAP has been working to create a network that supports a systems approach to improve soil health and reduce nutrient loss. The 15 member organizations work collaboratively throughout the year to provide consistent technical assistance to Illinois farmers and advisors on soil health and conservation drainage practices. More of our resources can be found at ilsustainableag.org. But for now, I will welcome ISAP's coordinator, Jean Brokish, to guide us through the rest of this afternoon's event. Jean.
Thanks, Megan, and thank you for joining us for our third and final session of this myth-busting series. I do have a few quick tips in terms of housekeeping in the GoToWebinar platform. You all should see a dashboard like the one shown on the slide here. If you don't see it, look for an orange arrow that either points to the left or points to the right, because that will allow you to expand and access your dashboard or minimize it during the webinar. The audience is on mute, so you don't need to worry about that. We will be interacting with you primarily 2 ways. The first and preferred way is to use that question and answer button to submit any questions throughout the webinar. And if you are interested in having your question posed to a specific panelist, feel free to tag them. You can submit a question at any time. And then you can use the chat. We do ask that you limit your use of the chat maybe for technical issues. If you're having problems hearing something or seeing something on the screen, you can chat the organizers and panelists or chat the staff, and we'll try to troubleshoot that for you. And then I guess the last kind of housekeeping thing before we start is just that we will be offering CEUs for today's webinar. This session has been approved for 1.5 hours in soil and water management, and the QR code will be shown at the end of the presentation after the panel discussion. So we'll give you a little heads up to get your app, your phone out, and if you have the CCA app, you'll have that ready. So I think without further ado, I'm going to go ahead and introduce our first presenter. I'm really looking forward to the discussion today and kind of teasing apart this myth that tile and conservation don't mix. Our first presenter is Dr. Ehsan Ghane. He's an assistant professor and extension specialist at Michigan State University, and where his research and interests are focused on the topics of water quality and agricultural drainage. Dr. Ghane provides education to diverse stakeholders, including producers, drainage contractors, crop advisors, conservation professionals, and agency personnel, and really just tries to translate his applied research into educational extension products. And Dr. Ghane is going to do actually a live demo of a online planning tool that he has worked on. So we've done we're in the process of a quick screen sharing change here. So I'll invite Dr. Ghane to just kind of pull up his presentation and make sure that we are good to go before he walks us through a roadmap for better tile drainage. So can you welcome Dr. Ghane. We can have you unmute, and do you have your screen available? Oh, you're muted, Dr. Ghane.
Okay, I unmuted. Can you hear me now?
Yes, we can hear you. Do you have your
no, I don't have the share privilege. Okay, now I got it. Thank you for giving me the access. Thank you so much, Jean, for the introduction. My name is Ehsan Ghane with Michigan State. I'm going to be talking about how to get the best out of your drainage system. So you should be able to see my screen.
Yes, and we see your PowerPoint file, not the presentation mode. So if you wanted to do that.
Now?
Yeah, it looks great.
Okay. So yes, I'm going to go through some tips. I'm going to spend some time on some of them, more time on some of them, and I'm going to skim through the rest. So let's see how we can get the best out of the drainage system. It's a big investment, and I'm sure you want to get the best out of your investment in the drainage system. So I'm going to go through drainage design. I'm going to talk a little bit about tools, and then shallow drains, drainage installation, another important one. Choice of pipe material is another one that I'm going to spend more time on it today. This is a new topic. It's only 6 months old that I've been talking about, and you're going to really enjoy that talk about the pipes. It's going to be new. And then there's drainage maintenance. There's the fifth one is impeded infiltration caused by salt compaction and dispersion. There's improving soil health, and then I'm going to end with the water quality comment at the very end. So let's get to business. So before we start with those tips, there's this definition about drainage underperformance. So it's a underperformance means that you paid for a drainage system to remove water at a certain rate, but it's not doing as it was supposed to and as it was designed for. So it's performing lower, and that's an underperformance. And that can cause loss of investment. For example, you paid for 30 feet drain spacing, but then the system is working as if you got a 40 feet spacing. So you lost money. You paid for that, but it's performing only as if you got a 40 feet spacing. That's just a simple example. You could have crop damage, water sitting on the farm. It's for too long, it's not draining, and it's going to have some crop damage. And it's going to have a water quality decline. That's an important one too, because if you have water sitting on a farm for too long, it's going to hurt and degrade the soil structure. And then it's going to cause increased surface runoff. And that's bad for water quality, because with surface runoff moves soil, and with the soil moves phosphorus. And we know phosphorus, we don't want too much phosphorus in surface water bodies. It causes algal blooms. That's a problem. So that's a definition, drainage underperformance. Let's get into some of those tips. So the first two that I described were design and installation. There's no time for it here to talk about this in depth, but basically, if you want to learn about design installation, there's a way, and that's education and training and hands-on experience with practice that you can get better at this. There's workshop in Illinois that teaches these, and pretty much in many other Midwest states, and I have one here in Michigan too. There's Ohio, Iowa, Minnesota, Missouri, South Dakota, North Dakota. So there's workshops around the Midwest to do some of that. But just briefly, keep in mind the best condition, the ideal condition is when the ground is the driest to install it. You want to avoid those wet conditions because it's going to cause soil compactions. And also, if you do proper installation, you're going to be reducing, and you're going to be avoiding the root and sediment clogging problems, because that's one of those problems that also causes underperformance. I don't have time for those, but if you want to learn more about those, there's information on my website. So let's talk about some of the design. So this is the point number one. This is the tip. There are decision support tools that help avoid those underperformance issues. The underperformance issues, like I described, is the drainage performing less than it was designed for. And you paid for such a design system, but it's not doing as it's supposed to. So these are the four drainage decision support tools. Let me briefly explain. So if you just do a search for MSU drainage, just remember MSU drainage, the first search that comes up is the first one that I clicked on is the Biosystems and Agricultural Engineering. This is the Michigan State University drainage resources for Michigan and the Midwest, for anywhere in the world. So if you go, so remember, let me just give you a brief overview of this website. So remember the underperformance that I talked about, this one? I clicked on it, and this is the root clogging. If, for example, you say, oh, I want to learn a little bit more, then this is the link, click the link to click. There's a sediment clogging resource. There is iron ochre clogging. This is another common one in certain areas. If you have iron ochre, you're welcome to click on that. Calcium carbonate clogging, and so on. So this is just a brief overview of the one topic that I didn't have time to discuss. So let's look at the tools. So I'm going to click on tools. Then over here, I'm going to have a set of tools that are useful for drainage design to avoid those underperformance issues. That's key. So the first one, briefly, it's called the Drain Sedimentation tool. I clicked on it, the new tab opened up. This tool helps you determine if you really need a protective measure against drain clogging with sediment. There's one of these videos here. I don't have time to show it to you, but it's one of those cartoons that explains it to you. So you're welcome to click on that and see how it's used. So for this tool, all you need is a soil sample from the drain depth, and then you plug those information like the percent sand, silt, clay in here, and then this tool will tell you, for example, you hit calculate. Drain sedimentation is not a problem. For example, you see when I clicked on it, this is what it does. So it tells you if you have a problem, and if you do have a problem, then you know you have the two options of a sand slot pipe or a sock wrapped pipe. Those are the two options. So the next tool was the sizing main tool. This is something very useful, and you can see these steps here: 1 ABC, 2, 3, 4, 5. So these are the steps. I encourage you to read the steps and follow the steps. But if you follow these steps, basically you can, for example, if I hit calculate, it gives me the size of the main in that certain location of the system that I'm trying to design. It's based on science, and it will size the main for you. So this is another important one. One thing to remember with these sizing mains is that, for example, you could be, remember I said you could have paid tens of thousands of dollars for a 30-feet drainage system. Lateral between the two laterals, 30 feet. You paid for that, but the system is working as if it's a 40 feet. The condition that it comes into play is that's called underperformance, by the way. So in that condition, the system is only going to work as good as the system the water can handle. So this is the tip. If you scroll down, drainage coefficient should be greater than or equal to drainage intensity if you want to avoid underperformance. This is very important. I made this tool because I felt there is a need. It's important because I have seen some instances that the pipe, the main is sized in such a way that it can handle, for example, quarter of an inch. I'm giving an example, but then the soil, water through the soil moves through the soil and into the pipe at half an inch, for example. But this is the limiting factor there. So this is helpful in the design to help avoid some of those underperformance issues. Another one that I thought it would be very interesting to make, this is the recent one. I made it in March this year. It's called splitting laterals. The splitting laterals you probably have in your state. So in Michigan, we have, let's say we have a 40 feet spacing system, and then the producer decides that they need more drainage, so they go halfway in between and split those 40 into 20. And then the question comes up from the drainage contractor or the design is that, okay, do I need to upsize the main, or did the previous designer 20 years ago, did he account for that sizing when he put that main together? This tool is the answer. I made this specifically for that, to get the guesswork out. It's going to tell you, do I need to, if I do a lateral splitting, am I going to need to upsize the main or no? So this is another one of those tools that can help you avoid underperformance. But the one I'm going to spend a little more time on is called the drain spacing tool. This tool this is a simple slide for the tool. I'm going to move back and forth. So this tool is going to estimate the spacing between those two lateral drain pipes, the two tiles. That's going to maximize economic return on investment. In other words, I can say simply, it's going to maximize profit. That's what it's designed to do. So that, like in this diagram, between the spacing between these two, it's going to be maximized for economic return on investment, meaning that it's going to have the lowest payback period. That's what the tool is trying to do. This is an example. Actually, it's in Urbana, Illinois. I have a 0 to 350 feet spacing on this axis. Here I have relative yield in percent, 0 to 100. And then here I have average annual return in dollars per acre. So if you're 0, it's just nothing. But if you're negative, you're losing money. If you're positive, you're making money. That's where you want to be. You want to invest and get a return off of that investment. So let's look at the yield first. This is what the yield looks like if at this soil, Urbana, from 1992 to 2019, you keep increasing the lateral spacing. You see, obviously this is expected, but what does it look like if you do profit? You're accounting for installation cost, yield benefits, all of the economics involved, and you can see it's low, but it peaks here and then it drops again. And that makes sense because at the beginning, you're getting this much yield, not much difference from here, but it's going to cost a lot more because it's narrower. So basically, the peak of that profit is going to be the optimum spacing that I'm talking about here. So here's the tool. The tool, one thing to remember about the tool, it has a GIS interface, and you can basically zoom in to the tool, and let me do an example. So let's say you can enter your address or just zoom in. I'm just gonna show you an example here. And if I select the tool, you select the box. If I hit like Marlette Loam, and then if I hit calculate for a target corn planting date, or I'm going to just say May 5th. And also I'm going to design it for a shallow drainage system, like 2.5. And if I hit calculate, it's going to give me the drain spacing that's going to maximize that profit there. Let's give it some time. So you see it tells me 30. And it's going to give you some other things, which I don't have time in this presentation, but you're welcome to contact me if you have more questions. But the tip for this tool that I have is that if your field, like this triangular field here, you see triangle, it has like two soils, Marlette loam and then another sandy loam. This tool is not intended for coarse textured soils like a sandy loam, because this is very fast drainage. So that's why the way to use the tool is that you go on the most limiting soil. You draw this just like I did, like that. You hit calculate, and then you get an output that tells you, this is 30. But if I try it for here, it's going to show me 71 or something like that. It's going to be really wide. But you would go based on the smallest one when you try each soil. So I did turn on the soil layer here. So this tool, like I said, it captures the weather information. You may ask, oh, why did you enter the planting date? By the way, this is the historical average. It's not for like 2022 or the next year, 2023 is not for the future, it's for the historical. So on average, in the past 30 years, when was your planting date for corn? It's approximately May 5th for Central Michigan, for the historical. And also it captures soil data from GSORGO or the Web Soil Survey from NRCS, and it estimates that as an estimate. So it gives you a guide. So whatever the guide it gives you, approximately plus or minus 5 feet of this would be your choice as a guide to go with. So that's the tool that I mentioned. Let me explain a little bit about the shallow drain that I mentioned. So these shallow drains, so this is an example of a deep drain, let's say 4 feet. I've seen these in Iowa, Minnesota, let's say 4, 4.5, or 5. even. So when you go deeper, you can put these spacings a little bit wider. It allows for a wider spacings if you do a deeper drain. But when you do a shallow drains, you're gonna need the narrower drains. You're gonna bring these to get together closer. And so the message here is that with the shallow, you're gonna come closer, the costs are gonna go up, but they're gonna be benefits. So let me explain some of the benefits. So the shallow drains, 28 to 30-inch depth. So these are installed narrower spacing. So we did some research on that, and this is what we found when we compared it to the deeper drain. We found that they lower water table more quickly. They reduce the risk of crop damage from waterlogged conditions. Like I mentioned, you're aware with the climate variability, you get the downpour of rain. This is gonna have quicker water removal compared to the deep one. It retains more moisture in the root zone. It's gonna reduce risk of crop drought stress in dry years. This is also what we found. It's going to increase. We also found that under certain conditions, you're going to get a boost in crop yield. And that was interesting, that under certain conditions, you're going to get less variability from year to year. That's another thing we found that was new. By that, I mean that from year 1, year 2, year 3, you're going to get about the same. It's not going to go year 1 a really high, year 2 really low. It has less change from year to year compared to the deep drains. It's going to reduce the total water drain, and it's going to have less days that it's going to flow over the year. And that is going to reduce nitrate loss. And that's an important water quality topic in Illinois and many other Midwest states. It's going to reduce nitrate. That has been proven with research. And another benefit is that it's not limited to just flat fields, just like controlled drainages. You know, if you know controlled drainage, that you have some restrictions on where you can put controlled drainage, but this is not restricted by the topography. It works on rolling and sloping land without any need for management. So that's shallow drain. Remember, it has its benefits, but alone, in our analysis, we found that even though it has some crop yield benefit in certain conditions, it's not enough to pay for the increasing cost. But still, they may be in the future, with the increase in downpours, there may be situations that it may be worth it. We did something for the historic analysis for the past, and we didn't do anything for the future climate change scenarios. But this is an interesting topic, and I recommend looking into the shallow drains. And I have an extension bulletin about that, again on that same website that I showed you. So let's spend a few minutes on this topic as well. This is the choosing the pipe material topic, and this is something new, like I mentioned early on, because this is part of that design actually. So let's say you design it, but you just call your supplier, say, okay, I want this pipe, when can you get it to me? And that's it. But there's more to it. I'm going to show you something that's going to improve your drainage system. So before I do, I'm going to explain some definitions. Rows of perforations. When I say rows of perforations, I mean for this example here, which is a staggered 4-row, this is what it looks like. This is what you're looking from the side. This is from the looking inside the opening of the pipe. You got 4 rows. And then this one is an 8-row pipe. So when I say 4-row, 8-row, this is what I mean. And so then when I say sand slot, this is what I mean. You can slide a piece of paper through it. It's very, very narrow. It's also called knife cut, ultra narrow cut, narrow slots, and different names like that. But this is what it means. It's a sand slot pipe. It's means for protecting against sediment coming into the pipe and clogging it. Opposite to that, if you don't have a problem, you use one of these pipes. It's called a regular perf, or regular perforated pipe. It's abbreviated as regular perf. So like I mentioned, if you have one of those drain sedimentation issues where the tool can guide you to avoid underperformance, you have 2 options. I explained the sand slot pipe option, which you have a narrow one. There's another option, it's called the sock wrapped pipe, where you have your regular perf pipe, you wrap a sock around it, and then you put it in. Both protect against drain sedimentation. And let's move forward. So I did experiments here in Michigan, and one of the things I found, let's say you have a drain sedimentation issue, we found that when you compare the 4-row sand slot, 8-row sand slot, and a sock wrap pipe, when you compare these three, you get the fastest and highest drainage with this one, with the one that's sock, and the slowest one with the 4. And then you may ask, okay, how much is this? Let me give you an example. So if, let's say you have a drainage system with 30 feet spacing and 2.5 feet drain depth, then you are going to have 29% high flow with that sock when you compare it to the 4-row. And 8-row obviously is in the middle in terms of how fast it drains. So it's a huge difference between the two, how fast it can drain. But of course, there's an extra cost with this sock that goes over. But the economics is complex because it also affects crop yield. So that's something, it's very site specific. So just to recap, both sock wrap and sand slot pipes provide adequate protection against sediment clogging. And if you're wondering which one can keep more sediment, there's research in Canada that showed that the sock wrap pipe keeps more sediment out of the pipe than a sand slot pipe. They both protect, so you won't have a clogging pipe, but even that finer sediment that can come in, the research showed that it's going to do better. The sock wrap pipe is going to maximize water entry into the pipe. It's going to flow in faster, and that's going to cause the water table to lower most quickly. Remember I said the economics is going to be complex because if you lower the water table quickly, you're going to have benefits. And the benefits of the sock versus the sand slot, if you install two systems with the same depth and spacing, is going to reduce the risk of crop damage after those heavy rainfalls because it's going to lower the water table most quickly. It's going to reduce the risk of delayed planting because of wet soil, and we found that it's going to have a modest increase in crop yield. So that's why it's going to be complex. It's going to be site specific. If you ask me, is it going to be economical? The answer is it's going to be site specific. And after this, if you really you cannot and you don't want to invest into that faster system, then between the two of them options of 8-row and 4-row, the best one is the one with the 8-row. It's still much faster than the 4-row. This is the tip that I mentioned I'm going to explain. And so just briefly about the properties. When let's say you don't have a sediment issue. Let's say you got a clay loam soil, for example. I'm making an example. You don't have a sediment issue. You don't have drain sediment issue. So you don't need the sock. You're in the other other scenario where you don't need it. So in that area, the take-home message is that the most important thing you want to look for is the 8-row. If you want to drain faster, you need to go with the 8-row, which is going to be much better than the 4-row for the same price. Imagine that. For the same price, you're going to drain faster with the 8-row than the 4-row. And the second most important one is the slot length. The longer, narrower slots are going to be better than shorter, wider slots. And then the slot width is not going to be important. That's not going to do much for you. So the message here is go with an 8-row if you want a faster draining of water. It's very simple for the same cost. It's going to drain faster. This is based on scientific research. And so this is my last slide. One other thing that I had was the soil health. About the soil health, let me actually show you that slide. It's the slide previous to this one. So one of the things is very important that you got to have a good soil health because the drainage system can't perform without a proper soil health. Because if that soil health has compaction problems, it's going to slow down water movement through the drain pipe. Examples are, you've probably heard about many different professionals talking about these things: reduce tillage, cover crop, reverse rotations. They can build organic matter, improve soil structure, and also increase infiltration, and then the water can move towards the pipes a lot quicker. So remember that, that's very important. So last slide, I explained several things, like the pipe's gonna drain a lot faster, and the tools are gonna help avoid underperformance. And those are all things that are gonna get the water away faster. But what happens to water quality? We gotta have to do something about that water quality. So this slide is about the water quality part. After we move the water so quickly, we gotta think about the water quality. One of the components is gonna be, you gotta have good soil health, you're gonna have nutrient management to apply what's needed. And also this water management is my area of work. Water management are, next speakers are gonna talk about some of that, like control drainage, saturate buffers, and other practices. These are all water management practices that can help reduce the nutrient and improve water quality. And so briefly, like I explained, the tools, installation, pipe, I explained the 8-row better than the 4-row. The impeding infiltration, you're welcome to look at the website for information about that, because that's another thing that can, that would take you away from the best of your drainage system. Improving soil health, and I explained water quality. Thank you so much. If you have any questions, we have a panel at the end.
Right. Yeah. Thank you, Ehsan. That was a really great overview of some drainage design and installation considerations. So I have a lot of notes. And again, a reminder for people, if you have any questions, to put those in the question box. And we're gonna, I guess, shift gears or just continue to build on this conversation here. Isaac Ferrie is our next presenter, and he's a certified crop advisor and director of research with CropTech Consulting. He is an SIU in Edwardsville. I was going to say you were an SIU grad, but I guess it was at the Edwardsville campus, earning a bachelor's degree in geography, specializing in GIS, and has also received a Master of Professional Studies from Northeastern University in Geographic Information Technology. He's been working hands-on since 2003, helping coordinate and implement many of the test plots that CropTech Consulting has been involved with each year. And Isaac is going to be discussing the benefits of managing that tile water. So Isaac, I think we have your slides here. You can just, we'll go to the next one and let you get started.
Sounds great. Yeah, so at CropTech, we do a lot of agronomic consulting, and a lot of that knowledge is gained through on-farm test trials that we do over multiple years, and this is definitely one of them. The next slide kind of shows how this specific farm is laid out. The part I'll be talking about here is 280s that are side by side, and it started off as a tile spacing plot. So we have 120-foot spacing, 60 and 30-foot spacing repeated in each 80, and then drainage just right down the middle that they actually flow onto. So we go to the next slide. Each of these tile spacings has their own outlet, which is a picture on the next slide. So it kind of made it easy for us as we were doing the spacing. We can monitor water flow, we can pull samples and look at nitrates and whatnot. And then after we concluded our water spacing trial, then we added gates into the system on one of the 80s to start to look at tile gate management. You can go to the next slide. And so with them each having their own main that comes directly into the outlet, it made installation pretty easy for each one of these spacings. And then we monitor, if you go to the next slide, we'll monitor water depth in these boxes. Now working with AgriDrain, we've installed sensors in there now where we can actually access the water level remotely and change the height of the gates remotely or let water go as we go through. But one of the things that we found out, even just doing our manual measurements and looking at the flow, is in this case here, we had a little over 1.5 inches rain on the night of the 21st a few years ago. And so we did measurements on flow before that, and then we came out that day multiple times, and then just about every day for another week, and how quickly in each one of our systems the flows actually peaked and then dropped off back to a minimal flow. Now, if we go to the next slide, one of the things we did see is that if you match up the corresponding colored arrows, in every one of our situations here, the gated side where we were holding water back did reduce overall flow and did end up in reducing overall nitrate load that was leaving in those systems compared to the ungated side. And if we go to the next slide, one of the things we did was kind of surprising is how quickly in our systems the peak flow was dropping off after these big rain events. And then when we go back and look at the nitrate samples we took at each one of those intervals to look at nitrate concentration, we realized during that peak flow we were losing about 8 pounds of nitrogen, per acre per day at that flow rate. But within 2 or 3 days, our flow rate was low enough that we were down to less than a half a pound, a quarter of a pound a day. So a lot of our loss, at least on this farm, is happening on the front end of those big rain events, that first push coming out the gate. And if we go to the next slide, one of the things we looked at overall in each of our spacings is when we looked at the overall loss and compared it to the rain events, we were losing about 70% of the nitrate that we lost per rain event was happening in the first 2 days. So that first water flush seems very critical to managing if we're trying to curb our nitrate loss overall. And if we go to the next slide, so it looks good on paper when we say, okay, in this rain event, our 120 foot, we had a 40% reduction in nitrate loss. And in our 30-foot spacing, we had a 16% reduction, partly because our 30-foot spacing, like we just heard, moves less water overall. And so those numbers are closer together. Well, those percentages are great, and that's really exciting. But for the farmer, it doesn't move the needle for us. So a 40% reduction is good if we're talking about the nutrient loss reduction strategy. But if you want a farmer to adopt it, telling him that he could gate his tile and save 5 pounds of nitrogen a year or 10 pounds of nitrogen a year doesn't move the scale for him. It isn't going to push him into doing that if it's going to cost a significant amount of money, time, or effort. And most of them are worried that if they start gating their tile, yeah, we'll save more nutrients, but do I reduce the effectiveness of the tile going forward? I put that tile in for a reason. I feel it's paying off, and if I start to block that tile going forward, I'm worried that I may not have the same effectiveness. So if we go to the next slide. So with historic end prices, if you're talking 5, 7, 10 pounds that we're going to reduce, and you're looking at 30, 50 cent in, economically, it doesn't bump it for the farmer. It's not enough to make him take notice or make major changes. And even at prices that we're having now at somewhere in that 90 cents to $1.20 a pound, it's still a pretty tough sell, especially if they're worried that their system's effectiveness will be in peril. So if we go to the next slide, so in this study, when we're looking at the spacings, it never really started off as a nutrient management study. It's all about yield and tile spacing. And that's really carried through into the gated part of it too. So we're more interested in yield because bottom line, that's what our farmers are most concerned with. But we're also watching the nutrient loss as well. So every single pass across this field, we stop on the ends, we unload into a scale cart or a grain cart with scales on it. So every single pass on this farm since 1999 has been weighed across both of these 80s, so we can evaluate yield effectiveness and get that history going forward. Now on the next slide, we also put water sensors or soil moisture sensors out here. So we're not only looking at where is the moisture level, how does it differ between the gated and ungated, but then we look at draw. So we can see the drawdown midday, where are the plants pulling the soil water from, where are they feeding from, and as we start to dry out on the surface, we can tell how deep the roots are and where they're actively pulling water from. Then we see that same thing in the next slide is that stable or sometimes rebound at night, where it's pulling that water up from down below. It has a chance to reabsorb that closer to the surface before we start all over. And that's what intrigued us a little bit. Is in the next slide, we see these big cracks out there, and we can go through a sizable dry period and we start to crack, and then we get a big rain, and when we go out there thinking everything's going to swell back together, and it doesn't. The structure is such, the preferential flow is such that we're taking a sizable amount of rain. It's going down these cracks. It's going through earthwork channels. It's making it to the tile too quick, and it's leaving the field. And we're getting a minimal amount of recharge on it, or essentially not as much as we think we could. And to close some of these cracks, it's taken 2 or 3 rain events close together to really get it to swell up. And this is where we started to see the real benefit of the gates going forward is, kind of like that hard sponge that's completely dried out. We dip that in a bucket of water and you pull it out real quick. You hardly pick up any water at all. But you dip it in that same bucket and you leave it in there for 30 seconds or a minute and you pull it out, and now it's softened and it's holding water. And with our tile gates, we're holding as much water as we can back in the beginning of the season. But by the time, well, even this week here before this last rain, we're not holding any water back this year. It's so dry, but we still have the gates closed. Well, when we had them closed and we get the big rain events, we hold the water back and we can go out there and check the gates, and we have water building up behind the gates. And then about 2 days later, you come back and that water's gone. But when that water disappeared, these cracks filled in or swelled back up. So for us, part of it was kind of holding the sponge in that bucket. Just by stopping the flow out of the field, we held water back long enough for the soil to actually re-grab that water and swell back up and increase our available water supply for those crops. And that in itself has equated to us for a yield benefit over the last 6 years or so. So it's about 2016. So if we go to the next slide, we're looking at just the years it's in corn. This field's in a corn bean rotation. We look at the different spacings, but our advantage to gating tile throughout the season and managing that tile water is, as low as 2 bushel per acre, but some years as high as 12, 14 bushel per acre by managing that water flow. And if we go to the next one and we average those spacings up, so we're as high as 12, but a multi-year average there of the different spacings around 9 bushel per acre. Even at past prices, 9 bushel per acre does get our farmers' attention. So now you come in and say, not only can we by chance lower nitrates that are leaving the field, but you think we could get a 9 bushel advantage if we started to manage that water. Now I'm putting it in and I'm getting a payback, plus I'm helping the environment and everything else. That's a lot easier to sell. And in some of these cases where it's 9 bushel and up, gets to be pretty exciting. At today's prices, it's really exciting. We also see a benefit in the beans as we go to that one. On the next slide, beans historically on our tile spacing do not respond as well to the tile. Our pattern tile as our corn did as far as overall tile benefit, but gating them did get a response. It's maybe not as consistent of the corn, but anywhere from a 1 to 7 bushel response. And if we go to the next one and we average those together, we're looking at a 3-4 bushel response on soybeans as well, which is really good. Now in 2021, we had multiple big rain events, and that kind of hurt us. So these are manual gates that we have to go out and open and shut. So we're trying to hold water back, and that's great. So even if there's a rain coming, we have the gates at least partially shut part of the way up there, and we're hoping to hold that water back. Well, then we had a couple 100-year rain events that dumped quite a bit of water in our area, and we were trying to hold water back. Then we got another rain event right on top of it and another one on top of it. And so we caused, I think, some duress on the crop by holding too much water back. Whereas if we had automation, it would have made it very easy to pull some of those gates and move forward. But as it stands now, they're hard to get out to in the field, depending on where they are on all the treatments, especially after a large saturating rain event. But 3 bushel on beans is really exciting, especially at today's prices. So we realized the tile has given us a benefit and a payback, and then all of a sudden, if you can add 3 bushel to the beans or 8 to 9 bushel to the corn, it can help cut your payback to the actual tile in half, really. And if we go to the next slide. So managing the actual water table for us has been a pretty tough goal because we can't hold it long enough. So we impact the water table height early in the season, but most of the time it's gone by mid-season for us anyway in these fields here. And then we're just trying to hold the rains back long enough to get the recharge we want throughout the soil. So that kind of changes our goal. We close them down in the winter, but when we come into spring, we let very little water go. So if we can get in there, plant it without letting any go, we're going to do it. If we have to, we're doing it 1 gate at a time, just to drain enough on to get the field where it is plantable to be able to get out there. We don't pull all the gates. We don't want to drop the water table down because most years in our experience playing with it, if we drop the water table down in the spring, we do have a hard time getting a sizable amount of water held back to be able to utilize. We're better off just letting enough go to get it planted and then closing back down. But our ultimate goal now with the gates is that sponge effect. These late season rains, when we get them in July and August, is where we have cracks in the soil, more preferential flow. We need to slow that water down from leaving the field. It holds the nitrates back because that big flush on the front end is usually our highest in nitrates, and it allows the soil to re-grab that water. Go to the next one. And really, so we're doing these gates up to this point very minimally managed. We want to manage them in the essence that the farmer would, or in the same manner that the farmer would. So we're trying to be realistic of the time and effort that a farmer will be able to allocate throughout the season. So we're only adjusting the gates probably 2 to 4 times throughout the year. We want to lower that top gate as we see large amounts of roots pushing deeper on our soil moisture sensors. So it's a fairly easy task under normal rainfall conditions, but it's exceptionally harder during adverse or multiple rainfall events, being able to get out there. And that's another thing guys are worried about, is what kind of time investment am I getting into if I have gates on all of my farms and I'm managing it. Our irrigation guys know all about that, as managing water is a full-time concern, but a lot of our irrigation guys have gone to automated systems they control from their phone. They can see the status from their phone, and makes their life a lot easier. And that's the next stage as we've installed the automation in these is can we do a better job of managing as we go forward by being able to do it remote. And if we go to the next one. And it also gives our farmers kind of an ease. So we could install these and someone else now could remotely manage that tile. I don't have to make the decisions on it. I don't have to be there every day. I have a professional that can see what's going on and make those adjustments. But for our customer base, it's definitely the yield advantages in the corn and the beans that are pushing the interest, not necessarily the nitrate load reduction that's happening, because the nitrate load reduction economically isn't a big enough drain on their overall pocket. But we do fight way more fear on how to properly manage those gates and make sure that they don't start backing up water, that they don't cause harm. And that's where the automation, I think, in that next spot is going to be huge. And that's all I have.
Great. Thank you, Isaac. That was a really good overview of kind of what the possibilities are and how you're managing them. And there's some questions I know that came in, and we'll get to those for you during the panel discussion. I'll go ahead and introduce our third presenter today. Jeff O'Connor is a 6th-generation farmer from Kankakee, Illinois. He earned his bachelor's degree in ag economics from the U of I in 1988, and he currently farms 800 acres of corn, soybeans, and wheat. And before you all joined us, we had a quick check-in with Jeff, and I know he's ready to start his wheat harvest this afternoon. So we really appreciate him taking some time and sharing his story with us today. Jeff has been using cover crops, strip till, and controlled water drainage for nearly 10 years and enjoys watching his soil structure and resiliency improve. He is a CCA with a Sustainability Specialist Certificate and also serves on the Kankakee Soil and Water Conservation District Board for 20 plus years and is a at-large director for the Illinois Soybean Association. So Jeff, if you're with us, I think, yeah, there you are, great. You will highlight tile's role in soil health and productivity, how it's working on your farm, and provide a valuable farmer perspective for us. So thanks for joining us.
Good afternoon, everybody. Thank you for coming into this program today. I know I'm the third speaker of the afternoon, which would put me in the position of I am one of the guys that you're talking to in the parking lot after a good seminar somewhere, and we're all trying to figure out what did we just hear, and you really want to talk to somebody who's done this before. I hope I can fill that role for you. So let's lean comfortably on the side of the pickup and talk about a few things we're doing on our farm here. Megan, thank you so much for that introduction. As I'm listening to this program today, I know it's very common for people to want to say how many generations they farm, but in this case, I was thinking about this. I am a third generation pattern tiling person. Both my father and grandfather have done pattern tiling. I grew up thinking that tiling happened every year and you picked up rocks every fall. And then I'm also a first generation cover crop advocate and have worked to be able to share how those two intersect and some of the benefits of the intersection of that. Where I live here in Kankakee County, we have anywhere from loamy sand that we farm on all the way up to clay loam. So we have the full gamut of soil types, and this area has extensively relied on drainage throughout its history. So that's where I can thank both my father and grandfather for the background that I have here. So if we want to go ahead into the slides that we have. So I think one of the first things that's important in any endeavor we want to take on is, why are we doing this? And if we first look at the drainage aspect of this, and this would be the oldest one for myself and my family, it's very obvious. We want to increase yields, we want to increase our profitability, and we want to be able to have repeatability with the drainage. When cover crops first started being talked about in the last 10 years, I'm fortunate that I already had a history within the family. Now, we didn't call them cover crops, but I do recall watching every year both my grandfather and father planting some type of cover on the sand hills that we have. Of course, at that time, tillage was done, and then we would try to seed them down to prevent it from blowing. And then in the spring, we'd have to work the sand hill 3 times to get it killed, and then it just blew again. We knew we had something we wanted to accomplish, and in this case, at that time, it was to reduce erosion. And what has that grown to be since cover crops have become a more common term, especially throughout the lifespan of the nutrient loss reduction strategy? We also knew that we wanted to be able to reduce nutrient loss. And then finally, as more of the science has come out, it has been, how do we improve the soil health? So you would think you have a great set of goals or why we're doing this on both sides, like it's illustrated in the screen. The problem began to be, as more people tried cover crops, we began to hear a little bit more about they don't mix. What we did see, and I say this on my farm at least, and you began to hear some people talk about, that there are actually some different factors coming into play when you paired them up. And what we were seeing here would be increased permeability on our farms, that we now were able to see that we had more days every year in the field in good conditions to be able to do the work. We've also seen an increase in water holding capacity, and that what science is now saying is that we can also begin to see some possible crop input reductions. Let's go to the next slide. For myself, one of the first things that caused me to really want to look into what cover crops could do for my farm is related to what tile water would be. I found it interesting. Isaac's research initially was from 2016. I found a graph in 2016 where I was testing tile water. But if you look at some of this older data, that matches up well with when the nutrient loss reduction strategy was first being talked about. When I first heard about nitrates in tile water, I wanted to find out if I was contributing to that problem, and if so, to what extent. Now, this graph right here, I'm fortunate there's one there's one section of land where we have similar soil types on 3 sides of an intersection. They're usually in the same cropping rotation, and they all had pattern tile systems. So in a very unscientific way, but in a way that a farmer might want to start to get a peek onto what's going on in his field, we went out into these fields working with the local water company, who was also interested in what type of nitrate loads might be reaching the Kankakee River. We started collecting water samples exactly like Isaac showed in the one picture, just holding a sample bottle in the tile outlet. We did this roughly every week for the time frame that we have here, and it looks like there's 8 weeks that we did this, 7 during the spring when the water would first start flowing, and then once again in July when we apparently had some heavy rains again. Now, the categories: early cover crop, I went back and looked. Early cover crop would have been a 35 pounds of cereal rye established that year. It was September 24th. The late cover crop was still cereal rye, but that was planted November 1st. These methods would have been at that time broadcast the cereal rye and lightly incorporated using a vertical tillage tool. But with any experience, a farmer would know that something planted in September probably had very thick growth in the fall with very dense cover in the spring. The late cover crop would not have done much in the fall, but by the following spring would have had considerable growth. Quick look at numbers. A tile system, all same soil types here, a tile system that did not have any cover, you see much higher numbers on parts per million of the nitrates. Early cover crop really so to dramatically reduce that concern over parts per million of nitrates that it was almost a non-factor. Late cover crop started slow but picked up later. You know, you look at those numbers. And there's a very significant difference there. Not science, one observation on my part, but it told me that I was going on the right path for using cover crops to try and reduce some of the nitrate loads that my farms may be putting into the water system. Next slide. So the actual myth that we want to get rid of here is that cover crops and tile don't mix. Part of where that myth comes from is that if we go back within the farming community 10 to 12 years ago, 2008, maybe up to 2012, that was a period where farm incomes were very good. Farmers were looking for ways to invest money. Tile was one of those. In that time frame, continuing to this day, there's a lot more tile put in that last 14 years going back to 2008 than you would have had prior to that, and a lot of pattern drainage. The picture on the right is simply from the 80s. It's an Illinois drainage guide that farmers would have used. The data in that would have not been much different from what it would have been 10, 20, 30 years prior to that. But farmers started to invest in more of that pattern tiling to fix not just the wet spots, but the whole farm. With the explosion in the amount of footage that went in for tile, obviously, if something is being done incorrectly, you're going to hear about it more just because of the frequency, and also because cover crops were starting to come into play. And if there was something that was done improper on the installation, you're going to hear about a problem, and that information is shared. The truth that we will find out here is that the cover crops by themselves are good, but if you couple it with a good drainage system, we're going to change dramatically that playing field, figuratively and literally, where we raise our cash crops each year. Next slide. So where does this myth come from? Well, it's very simple that we start talking about the different types of cover crops that we have, and it's like the rooting systems are different than corn and soybeans. They're very fibrous, it's more fibrous. They're going to be thinner in nature, and you know, they're really in that top soil profile there. But we were adding additional months of growing roots into the soil profile. The depths anywhere from 0 to 40 inches there, but really, since we're looking at small grains primarily, you're going to get in that 20 to 30 inch range where the most of those are at. That by itself shouldn't be an issue, because next slide will show corn and soybeans. They're going down, 4, 5, 6 feet as well. But if you at least want to look in the same profile that the cover crops may have done, we're completely covering that soil profile there. So there's really nothing different other than maybe the type of root system that you have, but that acre is being covered with roots down to the tile depth. So it's not a case of adding roots that weren't there before. It has to look like it's coming more back to what the installation was. Next slide, please. So the truth about the tile is most of the problems that we hear about come not from the fact that we're throwing the cover crops in there. It is how is that tile being put in. One of the new factors that came into play is that as farmers invested in tile, many farmers started doing their own tile they're new to it, so they don't have a lot of experience. And it doesn't mean that farmers themselves cannot install tile well. It just takes time to learn the ins and outs. When you talk to tiling contractors, I believe if you were to talk to any tiling contractor who's done it for a generation or 2 or 3, you will find they can exist. And usually what it comes back to is the type of connections that are used where laterals would be hooked into mains. You, at any point in time, with any growing crop, you can find roots in a tile system. Becomes when that plant is dead, the root dies, becomes weakened enough, and gets carried away with a flush of water. Are there obstructions that it can get hung up on? The type of connections that we use on our farm here with our installer is they will just cut a hole into the tile main, and they will actually stick the tile itself into that main connection, only about 1 rib, but then we cement around that connection to seal it tight and to give it the strength that it would need. Because there's only 1 rib going into the main and it's going to be on the top side of that main, there's very little surface for any roots or any debris that would flow through that system to be able to catch onto. So it's a question that I would implore that anybody who's going to be doing new drainage or adding cover crops into drainages, find out what kinds of connections you may have there. And you can never underestimate the value of consistent grade control. So an issue can stem from inconsistent and poor grade control, as well as the prior mentioned improper fittings and connections. There's always extenuating circumstances. My own tiling contractor has said, yes, he has seen once where annual rye had plugged a tile main. But when you ask more questions, they were quick to say, here was the problem. It was waterway work that was being done. They put tile in the waterway and the farmer seeded it down after installation to annual ryegrass. And he let it grow very thick. And that is a cover crop which can cause some issues. But it was a case where that cover crop in the waterway should not have been used at the depth that it was. And you can find those problems, but ask questions and find out why. So are we starting to show that, yes, the cover crops and the tile can work well together? Absolutely. In fact, the direction we're going to go with that next slide is let's now start to change the conversation from can cover crops cause a problem, meaning the negative, and focus on are there benefits that we can begin to see from the tile and water in the whole soil profile by some of the other practices we can also incorporate. And can we use it to not only have more trafficable days, but in the field, but more robust productivity? So beyond that tile drainage, are there those benefits? Do they exist? Next slide. So I want to talk about one project that I'm working with our local soil and water conservation district. And what we're setting up here and where we did this spring is moisture in the soil. We are in an area, we did not receive much rain over the weekend. We have cracks in some of the soil, but where is the moisture exactly at? I do have water control structures. What do those structures do for us? Where is the actual usable moisture at any point in time? So the first thing we're going to show here is that soil sensor, looking at the screen on the left-hand side. That is a soil sensor that is about the size of a hockey puck. And the thickness of the sensor is about the same thickness of the hockey puck there. And it's going to record soil moisture information wirelessly to the base station, which is on the edge of a field or on a nearby structure. And then we're going to use that information is going to be sent to the cloud and then back to the farmer's phone. Next picture. So what we did, the Soil and Water Conservation District has 4 cooperating farmers around the state, all with very different soil types, who had used cover crops in the fall. This is my field here that we're working with. And the cover crop on the left would have been cereal rye broadcast right at 1st of October. It was broadcast and not worked in. We had rain almost immediately, once again, about 35 pounds of cereal rye. And so it started growing right away. This field has also had no tillage whatsoever for 6 years. It has been strip tilled and then no tilled with soybeans, cover crops used wherever soybeans come in there. So this was established last fall. This spring, very early, as soon as there was green up on the cover crop, I went out there with a hand sprayer and terminated that cereal rye in roughly a 4x4 area so that we would have soil moisture readings and temperatures in an area where there were no growing cover crops, and we left the rest of the cover crop in the field to grow. The second picture is going to show us there where we actually installed this sensor into the ground, dug a small pit in the ground, making sure to not disturb the soil on one side. We went 3.5 inches down, and we inserted that soil moisture sensor into the side of that trench. 4 feet away, we did the same thing in the area where there was no growing cover crop, so that we could have within 4 foot, I don't believe our soil types changed that much, we could have instant readings on soil moisture and soil temperature. Next photo. On the edge of the field, then we put this base station. It is only about 50 feet away from where the sensors are. At that close of a distance and that depth, we could have the station quite a ways away. We're in great shape right there. And that information is sent back to the cloud and then to the phone, to where we can track soil moisture and temperature all the time. Now, the reason we did this, when there are cover crops in use, one of the myths, once again, we have a myth we're trying to bust, is that cover crops will slow down the drying of the field in the spring, and that they may have a negative effect on soil moisture because the ground looks like it stays wet longer. We wanted to prove on these 4 sites with 4 soil types that that is not the case, that the cover crops are not hurting our chance of planting early. And we found some pretty amazing things. Go ahead, next slide. So this is just a 1-month snapshot of what we saw on the farm here that I've illustrated for you. And so the green line is where we have a growing cover crop. The purplish line is where we had terminated it. Very easy to see, this is soil moisture. Remember, this is a sandy loam soil. So to me, this soil moisture percentages, it's a learning curve. This is where this soil is going to sit. You can see where all the rain events come up there. May 11th was the day that I actually planted this field. This was the first chance that we had to plant soybeans, and in this area we had a wet spring, not heavy rains, but we had enough moisture. And so what we've got here is I planted on May 11th. I will say I now know on that soil type, when the sensor says soil moisture is about 38%, conditions were perfect. And you can see where the cover crop was actually bringing that moisture down to that level quicker than where there was bare ground. I don't know why the purple lines stayed that high during that section, but this was the first time all year where we went into 90-degree weather with very high humidities, if that moisture was actually being drawn up nightly back to that area. And then you can see cover crop was terminated 2 days later. And since then, the last part of May into June, whenever we get a rain, you can see it spike up again. And you can see that that moisture, where the cover crop residue is, actually the moisture readings go higher around that sensor, tend to linger for a day, and then they're staying pretty consistent. Next slide shows something we didn't expect in that same time frame. Our cover crops, although the temperatures were a little cooler in that time frame, all those temperatures were still more than enough to germinate soybeans, but you can see some differences there between cover and no cover. And then the next slide would show the benefit. So if we look at what we've had here recently, where the cover crop residue is, our temperatures really seem to have peaked at about 86 degrees, but our straight no-till with no cover is getting up over 90. We do hope to expand this next year to include a tillage to see where those temperatures are at. Why is this important? Next slide. Well, what we want to do is be able to use all the moisture that does fall into a field. How do we keep it for the crop? This farm also does have these water control structures. There are 4 of them along the edge of a field. The tile on this farm is anywhere from 25 to 33 feet apart. It was an older system from the 80s that we added lines into, but we have these water control structures to be able to keep the subsoil moisture there as long as we can. They still are holding some moisture there. Why do we want to do this? Exact same reasons that Isaac highlighted, is we wanted to be able to keep nutrients there and keep all the usable water that we could. Next slide. There's an example if someone has not seen what does a structure look like when it's installed. On the left, yeah, it just sticks out of the ground maybe a foot. And a different application would be on the right-hand side is the field where the soil moisture sensors are. And you can see there are 3 of the 4 structures within this photo. But what I've done in this particular farm is the structures do stick out of the ground. I do not want to hit those, so I put in a 33-foot wide pollinator habitat to serve as a buffer. The tile main is also underneath of this buffer. So it is an edge of field practice, although you won't find it under most standard designs. I know the roots of these pollinators are getting down into that saturated zone where water is being held back and pulling some of those nutrients out. I could not do this without the confidence that the cover crop or the pollinators would prove detrimental to my tile system. So that's where, as you gradually learn, covers and tile do work. You can expand into practices like this and know with confidence it's going to work and you're not going to mess up your investment. So with that, I will wrap up. I do need to point out there's some contacts on there. The local Kankakee County Soil and Water Conservation District is doing this program this year. We're going to extend it into next year with a couple additional sites. We would like to be able to take some of these sensors and actually put them at greater depths to find out, now that we know how seamlessly the app and the sensors work to be able to read it from your phone. What if we were to put them closer down to where the controlled water is being managed? And now, instead of just guessing when to open and close, I can check my phone every day and see what those moisture levels are for that soil type and say it's time to open or it's time to close. Matthew Raymond is at contact there, and the other staff person with the district, Emily Watkins, helped greatly with this PowerPoint. Look forward to the questions anyone may have. Thank you.
Thanks, Jeff. That was a really good, I love the way you set it up. It was kind of that pickup discussion in the parking lot afterwards. So lots of great application of the things that we've been talking about. So just appreciate you sharing that. And I just invite all of the presenters to come back. We're going to shift to some question and answer session for the remaining about 15 minutes or so. And just another reminder, of course, to the audience to submit any questions you have. And I'm going to kick it off. I have a kind of a question. This is maybe to Isaac and Jeff both. You mentioned doing nitrate testing in the drain tile outlet water. Could you tell us who did those analysis for you? And I think one important context is that there's actually an attendee who is wondering about an at-home test, if there's any sort of opportunity to take your own grab samples and do an analysis that is high enough quality to give you some good data.
Yeah, I'll go ahead and jump in.
Jeff, go first, sure.
Yeah, I'll jump in there first. Our local water company, Aqua Illinois, is very interested in this as well, and we've had a previous working relationship. So their lab was very agreeable to bring up those samples and do that. We would not have had the means at that time to have done it ourselves, but I know some of that testing equipment has become more available, and we have worked, Soil and Water has worked with Farm Bureau to do some water testing since then.
Very good. Isaac, how about you?
We send all of ours to Midwest Labs in Omaha, Nebraska. That's where our soil testing goes. And then all of our, whether it's surface water or drainage water, we send out there.
Okay. And are either of you also doing flow to determine the volume? Because I think that's really important concept. You know, the concentration could vary, but we don't really know what the total contribution is if we're not multiplying it by the volume. So either of you were including that data?
Yeah, so we did, whenever we were pulling the nitrates, we did flow. Sometimes on some of our systems, they're just catches, right? So a 5-gallon bucket that we have a known volume in, and we're timing it with a stopwatch to get us to that point in time reference. But yeah, the flow is a big portion of it.
Okay.
We did not, Megan.
Okay, great.
Okay, one comment. So on the other side of the spectrum, if I have one of these, It's a test strip, if not for research grade, but if you just want to get an idea how it's doing, it has 0, 5, 10, 25. So you can get, are you a 10 milligram per liter or is it a 5? So this is I have one for phosphorus as well, for just for something very crude and simple.
And that's something that they can order from like an online catalog or something like that?
Yes, this is online and it's just for preliminary and you can get an idea what's going on.
Okay.
Yes.
Okay.
Yep, online.
Okay, that's a great tip. Thank you. And then I guess another question, Isaac, on your field trials where you were testing different spacing. What was the tillage regime and any other conservation practices that you were using along
So
with that
they're
field?
the conventional tillage, so a head of corn they'll chisel and then run a harrow, and then a lot of times they'll run like a vertical till harrow over the corn stalks or a chopper harrow before their beans.
Okay, and do you think like in terms of the cracking and things like that, I think one of the benefits that we've seen in terms of conservation and soil health systems is building up that organic matter. Any thoughts to whether that would impact, having a more conservation type soil health management system would influence the?
Yeah, I think it could definitely play into it, and maybe reduce some of that. The soil structure in this field, though, overall is very, very good. And it drains very quickly. The water moves through it very quickly. The pore space, just even like when we're digging in the field, as far as the crumb structure that's still there, and a lot of it has to come with the organic matter they're rolling back in. So a lot of 260 to 280 bushel, corn yields and residue that are getting rolled back into it. So there is a high amount of carbon that does get rolled back into there. But some of that cracking, potentially could be thwarted with some other measures. But nothing happens in a bubble, right? So in our other studies, we've seen where we can add cover crops to be able to stop some of that cracking and downward flow, but then we increase overland runoff. And so you have to watch that, like every consequence or every action in there is going to have some other consequence that's going to affect it. So it's never a one-to-one relationship. We just have to stop this because it could affect something else down the line.
Sure. Yeah, no, there's definitely a systems approach there. I guess maybe, Jeff, from your perspective, have you seen, maybe a reduction in cracking and through better soil health? And I guess I'm also kind of intrigued by Isaac's last comment there about cover crops increasing runoff. Have you seen that on your farm?
No, I have not. What we have found in our own farms is, and we have different soils. What we have found and I'll use one of Isaac's analogies before of the sponge, as we've increased the soil health, the organic matter, the porosity, we have actually found that the water is making it through the soil profile quicker. Now, how do we know this? These water control structures, the first one we put in on farm was one of the first ones AgriDrain ever did, was back in the mid to late 90s. Don't know an exact year. We have about 16 of these on different farms right now. Many of the farms are set up to where they're sequential. One area is held with a water control structure with 1 foot of elevation change on the land, and then we will set the tile was set up to where it then feeds into another one. We can see the progression of water in a field to where when one system fills up, it'll feed into the next one. Now, there's 2 different type of rain events. Well, there's 3. There's perfect, which we almost never have. There's the system where we just get these small light rains, and then we have these large deluges. What we've noticed when we have these areas where we get a 3-inch rain, just as Isaac mentioned, is we can look in these structures during a heavy rain event or immediately afterwards. And I hate to say it's something you get kind of geeky about, is watching these structures and see how they fill up to figure out how that water is going through the soil into the fields. We began to see a pattern of and we have very minimal grade here, of where the systems furthest back in the line were running full in the boxes, and they were getting high in there, but further downstream, there would actually be less water. We were getting so much infiltration on the upper ends that the tile main was getting full. And we've actually gone back and started adding additional mains to systems. You know, I showed a picture of a drainage guide from back in the 80s, which probably had data from 30 years before then. And if you still use those old numbers, which many of the old contractors would use, the mains aren't going to be sized adequately enough. So we have made it a practice. In fact, when my wheat comes out, there's another farm where 100 acres with a 15-inch main, we're adding another 15-inch main because the water is getting to that tile so quickly and filling it up, we can't get it away. That's where the structures are important, Megan. We want to keep it then when we get rid of the excess. The flip side, small rains, what do we see with these new sensors? Because of the amount of residue on the surface, the rate that it's dripping off, you know, the residue making it into the ground, we're actually getting moisture in the top 3.5 inches that seems to be lingering longer. I'm not a scientist. I don't really know what's happening, but what's neat to me is to know on these thinner soils, 8 to 10 inches of topsoil, if I can keep that soil moist longer during the hot, dry part of the season, that maybe these little rains can be utilized better by the use of cover crops and the proliferation of the roots in that top, you know, so far 3.5-inch zone. A lot to learn. I'd love to find researchers that can help with this, but it's very, I like the sensors.
Yeah, well, and I think you make a really interesting point, Jeff, about you know, increasing the infiltration. And back to Ehsan, your drain spacing tool that you demoed for us, you know, you really touched on how it considers soil texture. Is it also considering you know, infiltration rates, and particularly if we're increasing infiltration rates through better aggregation, et cetera? And you know, all of that is, I think, just kind of leading to this discussion of, is there a need for a new design book around tiling? So that's the big picture, but maybe you can start with a little picture in terms of what you see with infiltration changes and how your tool is handling that.
Yeah, well articulated question. I like that. Yeah, so like Jeff mentioned, the soil health is going to improve the drainage system's performance, and the tool, like I mentioned when I described the tool accounts for the soil properties, like the depth to restrictive layer, the satural conductivity, the properties of the soil. It takes into account the weather of that location. If you're if Jeff's farm rains more than here on campus, then that's going to need faster removal. It's going to need closer spacing. So you'll see that in the tool. That's why the weather is part of the tool. That's why we say our planting date is May 5th. If you enter another date, it's going to start capturing the growing season from that point onwards. So the weather is there. If it's wet, if it's raining more in some another state, because variations of rainfall, it increases as you keep going south. So in southern Illinois, it's going to rain more than here in Michigan. So it does account for the soil, but it doesn't account for because the soil data, the source is from the Web Soil Survey, the SORGO. So that it does not account for, let's say, decades of no-till or cover crop that improved the soil health. It's something that was taken samples decades ago, and they characterized the soil. That's just going to be a better improvement in the soil and the water movement from that. So there's no way to do that. That's very complex to account for that based on site specific, how much that improved. But the key message Jeff mentioned is that you got to improve the soil health, because that's going to be key as important part of the drainage system. And another point was that main, so if you're designing it, so the tool that I mentioned, the sizing the main tool, that's going to help you, going to take into account that soil, going to tell you can get the soil properties, and you can actually size the main so you can match how fast the soil can get the water to the pipe. Because if they don't match, if the soil can get the water to the pipe quicker than the pipe can't handle that, then you're just going to be wasting that investment.
Right. And so the investment, I think, you know, I've kind of heard different ballparks in terms of how quickly tile pays for itself. You know, what's the return on investment for tile? And so it's somewhere between maybe 5-ish, 7 years, depends on where your starting point is, of course. So question for you, Isaac, you talked about some of the gate structures as helping to make your investment pay off a little quicker. Do you have kind of a comparison of the ROI on tile alone versus the ROI with gate structures?
I think the ROI on tile alone is bigger than the ROI on gate structures, and that's all subjective of where you're starting at. Kind of like we had talked before, is we had spots in this farm that certain areas that paid for the tile within a couple years. And when we were evaluating our spacing, we actually had to remove those sections out of the data because that wasn't replicated across all the spacings. It just so happened that was in the 120-foot block, and that was kind of an unfair comparison. So there's definitely areas like that. As you have a 20-acre field or a 20-acre part of the field, there may be enough payoff there to pay for the tile all the way across the whole 80. Without having to get a benefit. Now, the other part that's hard is we plant this tile spacing plot whenever the no tile section is ready to plant. So it's not we go in at the 30s as soon as they're ready. We go in the 60s as soon as because then you're looking at a planting date plot. So we're holding back until the no-till is ready to plant the whole thing. But even in our 30-foot spacings, on some years, there are 15 to 20 more workable days in the spring in that spacing than there is in the no tile. And that right there for a lot of farmers would be enough. If you tell me there's no yield difference, but you can guarantee me 10 more days during my side dress season and 10 more days during my planting season, that's a risk management tool that's enough to pay for the tile in itself. And if I can get in 10 days sooner, that's huge.
Sure. And I was actually going to pitch a very similar question to Jeff along those lines. So, is there kind of a different timeline for return on investment under a soil health system, as you're kind of compounding those different benefits with tile?
I think that's research that needs to be done going forward. But in practice, I have found it to be beneficial and will continue to expand that. Technology gets better, it helps us to understand it. And really, Isaac said it very well. For me, what it's about is having the greatest amount of trafficable days that are allowable to me with causing minimal or no damage to my field throughout the whole year. That is what's paramount. I don't want to damage anything, protect the soil.
Well, I think, go ahead, Ehsan.
So I had a question once in the past. Someone said, oh, if you're improving soil health with these soil conservation practices and you're improving infiltration, the soil structure is going off, then we don't need drainage then in the future. So we don't need you. So then I said, no. If you improve soil health, yes, water can go in. You're going to reduce surface runoff. That's important. That's healthy soil, fertile soil on the top. But then it's going to go down. Then it's not going to have a place to go. It's just going to start to come up and it's going to drown the crop. So yes, we need it. Even we got to have both of them. We can't just, because of soil health, we can't put drainage away. We really need that for crop production.
Oh, well, I appreciate that wrap up. I thought I was going to give the last word to Jeff, but I'm glad you added that, Ehsan, because I think you're right. It just really brings it back to where we are, and we recognize the need for tile, and we recognize how this can work together as a system, and really just want to make sure we're maximizing both that water management and the nutrient management and the crop productivity components there. So with that, I will turn it back to Megan to do a quick wrap up and get you all out of here at 2:30.
Yeah, thanks, Jean, and thank you to all the panelists. I think we could have lots of discussion about a new design book. Maybe that'll be our new goal. But yes, we will get out of here by 2:30. Again, thank you to all. And I also wanted to say thank you to Helen Van Beck. She's also with ISAP. She's been doing all of our behind-the-scenes slide work for the past 3 weeks. We wanted to recognize her as well. But yes, feel free to get out your phone to use your CCA app. And if you don't have that, we'll also have a Google form. You can manually sign up for those credits after this webinar. So there it is for 1.5 hours. You'll also, everybody, CCA or not, will receive, when you exit this webinar, a pop-up window to do a 2-minute survey. And that really helps us as we gather information through the survey to share with other ISAP partners and funders. And it helps us understand and evaluate our efforts to hopefully create better programming in the future as well. And then finally, this concludes our 2022 ISAP Risk Management webinar series. If you missed any of the previous weeks or want to share them with other colleagues, please utilize ISAP's website where all 3 will be up shortly. And then you can also take a look at the events calendar, the other resources on our page there. It gets updated very frequently and also has a lot of specialists you can contact directly. So if you saw some speakers today or some other farmers in your area doing these practices, they might be on our website and available to contact for further questions. So again, thank you all for participating and for joining in the discussions, and we hope that you have a good afternoon. Thank you.